The impact of Mercury's slow rotation. When we think about planets in our solar system, we often think about their size, their distance from the Sun, and their atmospheres. But there's one critical feature that often gets overlooked: a planet's rotation. Mercury, the closest planet to the Sun, has an intriguing characteristic: its rotation is incredibly slow. It takes 59 Earth days to complete just one full rotation. In this video, we'll explore what the consequences of Mercury's slow rotation are, and how this unusual feature affects the planet in ways that are both fascinating and extreme. Mercury's slow rotation creates a number of extreme conditions on the planet's surface. Its day, what we call a Mercury day, is almost 2/3 as long as its year, which lasts just 88 Earth days. So every day on Mercury is almost twice as long as its orbit around the Sun. This slow rotation leads to intense temperature variations between day and night. During the day, the Sun beats down relentlessly on the surface. Since Mercury is so close to the Sun, temperatures can rise up to about 800 degrees Fahrenheit, 427 degrees Celsius, which is hot enough to melt lead. However, because Mercury has no atmosphere to trap heat, the temperature plummets during the night, dropping to minus 330 degrees Fahrenheit, minus 201 degrees Celsius. These extreme shifts in temperature make life, as we know it, impossible on Mercury. One of the most significant effects of Mercury's slow rotation is the fact that the planet doesn't experience a traditional day-night cycle like Earth. On Earth, the day and night cycle has a rhythm that helps stabilize temperatures and creates patterns in weather and life. Mercury, on the other hand, experiences long periods of daylight and darkness. Each day on Mercury lasts about 176 Earth days, meaning that one side of the planet faces the Sun for almost 2 Earth months, while the other side remains in darkness for the same amount of time. This long exposure to the Sun means that areas on Mercury's surface closest to the Sun, such as the planet's equator, experience the hottest temperatures. But the other side of the planet, the night side, experiences a near-permanent state of cold. This imbalance in temperature creates an unstable environment, where the extremes of heat and cold could potentially cause the surface materials of the planet to crack, shift, and erode. Another consequence of Mercury's slow rotation is the planet's magnetic field. Unlike Earth, Mercury has a weak magnetic field, which is only about 1% as strong as Earth's. This field is likely influenced by the planet's rotation. A faster rotation could help generate a stronger magnetic field, which could, in theory, provide some protection against solar winds and cosmic radiation. Since Mercury rotates so slowly, it doesn't generate a strong magnetic field to deflect these dangerous particles, leaving the planet vulnerable to the Sun's intense radiation. The slow rotation also affects the planet's atmosphere, or rather the lack of one. Mercury's thin exosphere is made up of particles like oxygen, sodium, and hydrogen, but because the planet doesn't rotate quickly enough, it can't retain an atmosphere the way Earth can. The lack of a strong atmosphere means that Mercury is unable to moderate its temperature or protect itself from harmful solar radiation. This makes it a hostile environment where survival is impossible for anything we know. But it's not all bad news for Mercury. There's one unique feature of the planet's slow rotation: its terminator line. The terminator is the boundary between the sunlit and shadowed sides of the planet. Because of Mercury's rotation, the Sun rises and sets very slowly, creating an extended twilight zone where temperatures aren't as extreme. This area, while still inhospitable, might be more stable in terms of temperature compared to the extreme hot and cold regions. Mercury's slow rotation also has an effect on its solar day, which is different from its rotational day. The solar day on Mercury is 176 Earth days long, but because the planet moves around the Sun during its slow rotation, the Sun appears to rise and set only once every 2 Mercury years. This means that if you were standing on the surface of Mercury, you would experience a very long day followed by an equally long night, with no sunrise or sunset happening in the traditional sense. This unique experience gives Mercury a rather strange and extreme version of what we consider a day. One interesting consequence of Mercury's slow rotation is that it might allow scientists to study the planet's surface and its dynamics in ways they can't with other planets. The slow rotation means that any particular area on the planet's surface experiences prolonged sunlight and darkness, giving researchers the ability to gather more detailed data on how temperature fluctuations affect the planet's surface. Instruments placed on Mercury could help scientists better understand the effects of extreme temperature variations and how these could impact planetary geology and surface materials. Mercury's slow rotation also gives us a unique perspective on how planets interact with their environment. It's the product of a phenomenon called tidal locking, when a planet's rotation slows down due to gravitational forces, eventually leading to one side always facing its star or planet. This process has occurred on Mercury over millions of years, and it will likely continue to affect the planet's rotation for eons. Understanding tidal locking on Mercury can give scientists insights into how moons and planets evolve, and how their orbits and rotations can change over time. In conclusion, Mercury's slow rotation has a number of fascinating consequences. From the extreme temperature fluctuations between day and night to the unique characteristics of its day and night cycle, Mercury is an extreme environment that challenges our understanding of planetary science. While its slow rotation leaves it vulnerable to solar radiation and creates inhospitable conditions for life, it also provides a unique opportunity to study planetary dynamics and the effects of tidal locking. Mercury's strange rotation is just one of the many features that make this small, hot planet an object of intrigue for scientists, and it's a reminder of how much there still is to learn about our solar system.